Real estate property scraping and visualization. Introduction to scraping real estate data using Python. See how to extract and visualize property data from a sample website. Learn why web scraping is a valuable skill for data mining. We will use Pandas, requests, and Beautiful Soup libraries. By the end, you will be able to collect and plot property information. Running the cell now. What is web scraping? Web scraping means collecting data from web pages automatically. It helps extract useful information from websites for analysis. This is often used in real estate, finance, news, and many other industries. The Python libraries we use will make scraping easier. Let us see how it is done with real examples. Running the cell now. We begin by turning off warning messages. This makes the output cleaner and less distracting for beginners. Suppress warnings for a cleaner output. Import warnings, warnings.filter warnings, ignore. Import numpy as np. We set the random seed to 42 for reproducibility. Running the cell now. Here, we've set up our coding environment by suppressing warnings and fixing the random seed for reproducibility. Although there's no visible output, this step ensures our web scraping and data processing will run smoothly and consistently in later examples. It's a simple but important preparation before we start extracting and analyzing real web data. Now we are ready to start coding, and any warnings will not clutter our output. Let us load live sample data from a test e-commerce site with property-like listings. The code below uses requests and Beautiful Soup to grab product details. Data setup. Import requests. From BS for import Beautiful Soup. URL equals https://webscraper.io/test-sites/e-commerce/static/computers. HTML requests.get URL.text. Soup equals Beautiful Soup HTML.parser. Cards equals soup.select.thumbnail. Records equals title c.select_1.title.get_text. Strip equals true. Price c.select_1.price.get_text. Strip equals true for C in cards. Print records 5. Running the cell now. This output shows a list of dictionaries, each containing the product title and price scraped from the web page. Notice how the code extracts only key details, product names and prices, from the HTML elements with specific classes, demonstrating a basic but powerful way to collect structured data from a web page. This sets the foundation for automating data collection using Python libraries like requests and Beautiful Soup. We just scraped a few property records. Each one has a title and price, just like a real estate listing. This is a safe demo site for learning. Printing the first 5 records lets you see what kind of information we collected. Now let us put our scraped data into a Pandas DataFrame. This is a table format that makes analysis and plotting much easier. Convert records to Pandas DataFrame for easy analysis. Import Pandas as PD. df equals PD DataFrame, records. Print df.shape. Print df.head. Running the cell now. Here, the output shows a data frame with 3 rows and 2 columns, named title and price, representing product names and their prices scraped from a web page. Notice how converting the scraped records into a data frame allows us to easily view and analyze the structured data, which is the first key step in processing scraped information for further use. You see how many rows and columns we have, and you get a quick preview of the data. With Pandas, it is simple to explore and manipulate the scraped records. Quick look at the data. Let us review what columns we have. Each row is a property or product, almost like a real estate listing. Columns help us filter, sort, and plot data later. Running the cell now. It is important to confirm what columns exist and if there are any missing values. Missing values can cause problems when analyzing or visualizing, so we check early. Check column names and missing values. Print df.columns. Print df.isnl.sum. Running the cell now. Here we see the dataset contains two columns, title and price, with no missing values in either. This quick check confirms the data is clean and ready for analysis, helping us understand what information each row holds, like a listing's name and its cost, before we filter or visualize it. If you see all zeros, there are no missing values, and we are ready for the next steps. If there are missing values, we would handle them by filling or removing gaps. Often price fields include symbols like the $sign. We remove the symbol so price is stored as a number, which lets us calculate and plot. Clean price column, remove currency signs and convert to float. df price equals df price dot street replace $.astype float. Running the cell now. Here we cleaned the price column by removing the $signs and converting the values to floats. This step is crucial because it transforms the price data into a numerical format that can be easily filtered, sorted, and analyzed in later steps. Notice this prepares the dataset for more effective comparisons and visualizations of property prices. Now our price column has numeric values only. This is great for plotting or comparisons. Why preprocess the data? Clean data avoids mistakes in charts and calculations. It is a key step in any data mining process. Always check types and fix problems early. Running the cell now. Let us see basic statistics for the price column. This will show us the minimum, average, and maximum prices, which are useful to understand what we scraped. Show the basic statistics for the price. Print df price.describe. Running the cell now. This output summarizes the price column, showing there are 3 valid entries with an average price around 764 and a wide spread, indicated by the large standard deviation. Noticing these stats helps identify unusual values or data quality issues early, reinforcing the lesson's point that checking and understanding your data's shape is essential before further analysis or visualization. You can quickly see if prices are mostly in one range or if there are some very high or low values. This step helps you notice outliers and spot check if the scraping worked correctly. Visualizing prices helps you see how your data is spread out. A histogram is a bar graph that shows how many listings fall in different price ranges. Plot a simple price distribution. Import matplotlib.pyplot as plt. plt.figure, figsize sad smiley 8, 4. plt.hist, df, price, bins equals 10, color equals sky blue, edge color equals black. plt.title, distribution of scraped property prices. plt.xlabel, price. plt.ilabel, count. plt.show. Running the cell now. This histogram shows how property prices are distributed in the dataset, highlighting the frequency of prices within specific ranges. Notice the shape and spread of the bars, which can reveal any outliers or unusual patterns before deeper analysis. Plotting this early helps confirm that the price data is clean and reasonable, supporting accurate insights later on. You will see which price ranges are most common among the properties scraped. Visual charts make patterns easy to spot, even for beginners. Explore listings with the highest prices. Sometimes it is useful to focus on properties with the highest value. This can show what luxury features or locations appear in pricier listings. Running the cell now. Now let us sort our data by price, from high to low. This lets us check for luxury or outlier properties easily. Display top 5 most expensive listings. Print df.sort_values, price, ascending equals false, head. Running the cell now. This output shows the top 5 listings sorted by price in descending order, highlighting the most expensive items first. Notice how the highest prices significantly exceed others, emphasizing which listings fall into the luxury category. This helps identify what features or products command premium prices, aligning with our goal to explore high-value properties. Here are the most expensive properties currently scraped. This can be useful when looking for trends among premium listings. Let us make it interactive. You can pick a word, and we will show listings that match it in the title. Search for a property keyword using input. Keyword equals input, enter a keyword to search titles. Matches equals df, title, .street lower, .street contains, keyword .lower. Print, matches. Running the cell now. The output shows an empty data frame, indicating no listings contain the keyword you entered in their titles. This highlights the importance of choosing relevant keywords when exploring high-priced properties, as an unmatched term results in no data to analyze. Such filtering helps focus on specific luxury features or locations linked to top-valued listings. Try entering words like laptop or monitor, depending on what you are curious to find. Being able to filter by keywords is handy for market research. Pause the video now to experiment with some searches. Data mining. What insights can we extract? Web scraping lets us answer questions such as: which product types are most expensive or cheapest? How many listings mention a certain brand or keyword? What is the typical price range? These basic insights help investors, buyers, or analysts make decisions. Running the cell now. Let us check how many listings include the word laptop. This is an example of simple text mining, finding how often a keyword appears. Count how many listings contain the word laptop. Laptop_count equals df, title, .street lower, .street contains, laptop, .sum. Print, f number of listings with laptop_count. Running the cell now. This output shows that none of the listings in our dataset mention the word laptop in their titles. This result highlights how keyword searching can quickly reveal the presence or absence of specific product types, which is essential for understanding market availability or focus areas in the scraped data. This counting technique can be used for any brand, feature, or keyword you are interested in. It is a basic but powerful way to summarize your data. To spot trends, let us check which words appear most often in the titles. We remove common words like and or the so the chart focuses on useful keywords. Create a bar plot of the top 5 most common words in titles. From collections import counter. Words equals .join, df, title, .lower, .split. Stop words equals set, and, or, the, with, for, of, by, to, in. Filtered equals W for W in words if W not in stop words. Top 5 equals counter, filtered, .most_common, 5. Labels, counts equals zip, asterisk top 5. plt.figure, fig size sad smiley 7 4. plt.bar, labels, counts, color equals orange. plt.title, top 5 words in property titles. plt.illabel, count. plt.show. Running the cell now. This bar plot highlights the top 5 most frequent words appearing in the property titles, filtering out common stop words to focus on meaningful terms. Notice how the counts reveal which keywords dominate listings, helping us understand what features or types are emphasized in the market. This insight is useful for identifying popular trends or key selling points that influence buyer interest. You can now see which product features or brands appear most often in these listings. This helps us guess what is popular or in demand. Mini project, try scraping another site. Find another e-commerce or listing site with a safe terms of use. Try changing the URL variable to a new site and adapt the code. Can you scrape product names and prices from a different category? Remember, always check the website rules before scraping. Running the cell now. Let us save our cleaned and analyzed data for future analysis. Exporting to CSV allows you to use this data in Excel, machine learning projects, or to share with others. #export your clean data for later use. df.to_csv, real_estate_scrape.csv, index equals false. Print, saved as real_estate_scrape.csv. Running the cell now. This output confirms that your scraped and cleaned real estate data has been successfully saved to a CSV file for future use. Notice there's no data preview here, just a simple message indicating the export step worked as intended, which is crucial for preserving your results after adapting the scraper to a new site. This step connects to the lesson's goal of handling and storing scraped data reliably from different e-commerce or listing sites. Your CSV file is now saved and ready to use anywhere. You can now reuse this data for more analysis later. What else can you do next? Try grouping by keywords or sorting differently. Experiment with more advanced plots like scatter charts. The more you explore, the more insights you find. Subscribe to the channel for more hands-on Python data mining lessons. Running the cell now.